Welcome! In this video, I'll show you how to solve problem 6.17 as it appears in the third edition of Griffiths Introduction to Quantum Mechanics. The problem states the following. It says, the exact fine structure formula for hydrogen, which is obtained from the Dirac Equation without needing perturbation theory, is that beast. We want to expand to order alpha to the fourth, and note that we recover the result found using perturbation theory. Okay, so this result right here comes from relativistic quantum mechanics, where we use the Dirac equation, which is kind of a better version of the Schrödinger equation, and there this result just comes naturally. We don't need to use perturbation theory to find it, it just comes naturally when you solve the hydrogen atom, which is very cool. So we want to show that if we take this exact expression and we approximate it, we can find the approximate expression that we used in perturbation theory. So let's do that. Now, how can we simplify this horrible monster? Well, let's go from the inside out. And what is on the inside? Well, we have this square root. So let's work on that. So the square root of j plus 1/2 squared minus alpha squared. Okay, so how can we do anything about this? Well, whenever we have a square root and we want to approximate it, what we want to do is leave it in the form of 1 plus something or 1 minus something, and that hopefully the something will be very small. So we have to factor one of these two out. We can either factor out alpha or j. If we factor out alpha, we are going to get something like 1, actually, yeah, it's going to be minus 1 plus, and then we have this j plus 1/2 divided by alpha squared. But since alpha squared is very small, this number will get very big, and we don't want this. Whenever we approximate something like this, we want that thing to be very small. So that means, okay, this was not the right approach. So what we want to do is isolate, or basically factor out not the alpha, but the other thing. So this j plus 1/2 squared. So let's do that. So the square root of, and now let's factor out j plus 1/2 squared times 1, right? So this was the first part, minus alpha squared divided by this. So we didn't really change anything here. So now we can pull out this from the square root. So we get this is equal to j plus 1/2 times the square root of 1 minus alpha squared over j plus 1/2 squared. Okay, so now we have this square root, which is 1 minus something small. Okay, so how do we now continue? Well, let me remind you of a very nice trick that I hope you have seen before. If not, I will teach you how to use it. And that is use the binomial theorem. So the binomial theorem tells us that if we have 1 plus y, and this is to the nth power, then this can be found by using the sum from k equals 0 to infinity of n over k y to the kth power. All right, and why is this so useful? So let me just write this out explicitly. So I will just write out the sum. So if we do the sum beginning with k equals 0, we get n over 0 times y to the 0th power, which is 1, plus n over 1 times 1 to the y to the first power, plus n to the second power, and n over 2 times y to the second power, and so on and so forth. And what would be n and y in our case? Well, in our case, y would be minus alpha squared over j plus 1/2 squared, and n would be 1/2. But the thing is, we don't want to go any further than alpha to the 4th power. And if we keep terms that are higher than just y, we will already have reached that limit. So when we then multiply by alpha again, it will already be alpha to the 5th power. So what I recommend you do here is that you think about it, because whenever you are doing these approximations, you need to keep into consideration to which order do I want to do this. They tell us in the instructions we want to stick to below alpha to the 4th power. And since when looking at this, we know that we are going to be squaring this parenthesis, right? We're going to be squaring it. So if we already have alpha to the 4th power and then we or to the second, sorry, is to the fourth because we already squared it, and then we have to square it again. This is probably gonna go way too high. So that's a good indicator that we should probably not keep this part. If you're unsure, you can keep it, and later in your calculations, when you see that you encounter alpha to the fifth or something like that, then you say, okay, this was too much, and you just neglect it and continue. Okay, so that is a way in which you can go ahead and just be sure that you didn't make a mistake. All right, so let's now plug our values into this. And maybe let me write this out explicitly in case this is not entirely clear. So n over 0 is n factorial divided by n minus 0 factorial times 0 factorial. All right, and well, n minus 0 factorial is simply n factorial, and 0 factorial is 1. So this entire thing is 1, right? Because the n factorials cancel each other out. And here, what do we have? This is going to be n factorial over n minus 1 factorial, 1 factorial. But 1 factorial is 1, right? So just bye-bye. And n factorial we can rewrite as n times n minus 1 factorial. So these two will cancel out once again, and all that will be left is 1 plus n times y. Amazing. So let's now plug our values into this. So 1 minus alpha squared j plus 1/2 squared, and all of this to the 1/2, right, square root. This is going to be, let's see, 1 from here, this 1, plus n, which is 1/2, times y, which is this thing. So we have a minus sign, which will now go here. So we get minus alpha squared divided by j plus 1/2 squared. So this is what we now have to plug in. So let's now go back to here, and instead of this square root, we plug in what we just found. This. All right, so we can now multiply through. So we get j plus 1/2 from this part, and then this will simplify a little bit here. So we get minus alpha squared divided by 2j plus 1/2. All right, this is kind of awkward, I guess. Let me fix it. Okay, so we now simplified the square root. Next step would be to go one step further out, right? We went from the very inside and we are slowly working our way out. So let's now take this entire thing here. All right, so we have alpha over, it's n minus j plus 1/2 plus the square root, I believe, right? Yes, and the square root we already know is j plus 1/2, and then we have, why is my memory so bad? Minus alpha squared over 2j plus 1/2, and I'm checking because I don't want to make a mistake. Okay. All right, and all of this is squared. So this is what we now want to simplify or expand, depending on what can happen. So first of all, we notice that this and this are exactly the same. So they cancel each other out. All right, so that's very nice. So these two gone. So all that we are left with is alpha over n minus alpha squared divided by 2j plus 1/2 squared. Okay, so what exactly do we have here? So maybe let's take the alpha outside, right? So we can take alpha and put it here, alpha squared. We took it out of this bracket. And now we have 1 over this thing. So basically, we now have alpha squared times n minus alpha squared divided by 2j plus 1/2, and all of this squared. So this is kind of, you know, oh, and this is, sorry, this is to the minus 1 power and then squared, sorry. So this is to the minus 1 power and then squared. So the thing is, this is slowly working its way to look like something where we can use the binomial theorem again. So if we factor out this n, we can make it much clearer. So we can write it as alpha squared divided by n squared times, then what do we have? Then we have 1 minus alpha squared divided by 2n, right? This n has to be here since we factored it out. J plus 1 over 2, or 1/2. All of this to the minus 1 and squared. You can also write it as minus 2, but I think it's going to be simpler if we keep it this way. Because now this is something of the form, at least the inner part, this is something of the form 1 minus y, or you can call it plus y if you consider y to be negative, to the minus 1 power. And now we can go back to where we found this formula, right? So let me get rid of this. And let's apply now our new conditions to this. So what was our new y? I legitimately don't remember. It's y is minus alpha divided by 2n j plus 1/2. Maybe let's double check. 2n j plus 1/2 alpha squared. Sorry. With a negative sign. Did I include that? Yeah. All right. I included the negative sign. Okay. And n is minus 1. All right. That's pretty good. So let's take a look at what we're dealing with. We are dealing with something where we already have an alpha squared multiplying. So that means that when we are done with this, we are going to have, already an alpha squared. And why is this relevant? Because once again, we don't really want to go, too far into our approximation. But I'm going to show you, what would happen if maybe I didn't think of this. Maybe I'm not sure where I should stop my approximation. Where should I stop expanding? So I'm just going to naively expand one order out too far. Okay, so let's do it. Now, what is n over 2? Because we now need to include this, right? If I'm going to go further. So n over 2 is n factorial, n minus 2 factorial, 2 factorial. And similarly, as we did before, n factorial is n times n minus 1 times n minus 2 factorial. So the n minus 2 factorials cancel out, and we are left with n times n minus 1. And then we have this 2 factorial here, which is simply 2. So let's expand to this order. All right, so this means that 1 minus alpha squared over 2n j plus 1/2 to the minus 1 power. This is 1, right, this one, plus ny. N is minus 1, y is this. So we have minus minus, so we get plus alpha squared over 2n j plus 1/2. Okay, and now we go to the second order. Here we have n equal minus 1, so we get minus 1, and then we have minus 2, so we get plus 2 divided by 2, which actually cancel out. So we get y squared. And what is y squared? It's going to be this thing squared. So the minus sign cancels out, and we get alpha to the 4th power, 4n squared, j plus 1/2 squared. All right, and now we want to plug this back where we just found it. So this now goes, I believe it is here, yes, but I'm kind of running out of space, but yeah, maybe let's go to a new page. All right, so it goes here, and this was still multiplied by alpha squared, n squared, and all of this was still squared. So we still needed to square that. All right, so here I guess it becomes a little bit more obvious that if we keep this, we are going to have this thing squared where the smallest term, you know what, I'm gonna do it explicitly. So this is 1 squared, right? So considering all the terms that will involve this, it's going to be this squared, which will have something of alpha to the 8th power, which is obviously way too high. Then we have something which is going to be this times this, which will be alpha to the 6th power, which is also way too high. And then the lowest one will be when we multiply this with this, where we will have alpha to the 4th power, which is in principle okay, but the thing is we still have to multiply with the alpha that is outside. So even the lowest part will still go to alpha to the 6th power, right? So this is just way too high. So this entire thing here shouldn't be here at all, all right? Which is nice because this makes this calculation a lot easier. So let's expand this. Let me move it. There we go. All right. So this is going to be alpha squared n squared 1 plus, and then we have 2 times this. So alpha squared over n j plus 1/2, and then plus this squared. So plus alpha to the 4th power over 4n squared j plus 1/2 squared. But here, once again, we have a problem because this part already has an alpha to the 4th power. So when we multiply with this one, we are going to go to alpha to the 6th, which is way too high. So this one will just have to be neglected. And that is okay because it's a very, 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 very small one, right? It doesn't make, it barely makes a difference. It's like thousands of times smaller. All right, so let's now keep these two. So basically our result here is going to be alpha squared over n squared plus alpha to the 4th power n cubed j plus 1/2. All right, so our entire like huge beast that was this inner thing has now been reduced to what we just saw. All right, so here's our result. This is what we have. And now let us plug it in. So maybe I'm gonna replace it and continue working here so we don't lose track of our goal. All right, so this is this inner bracket, which is the one that is squared. So the next part will be to include this 1 plus. So now we go to this bracket. So we get 1 plus what we just found. 1 plus this. Okay, and all of this is now raised to the minus 1/2. So what could we do here? All right, maybe pause the video, try to figure out by yourself. Spoiler alert, we're going to use the binomial theorem once again. Okay, so we can consider this entire thing here to be y, and n would of course be this. So let's now go back to our formulas, which is here, and apply now this new set of circumstances that we have. Okay, so maybe in fact it would be easier if I hadn't expanded it, but I guess it doesn't matter. So y is now alpha squared over n squared plus alpha to the 4th over n cubed, and I already forgot the rest, j plus 1/2. J plus 1/2. And n is minus 1/2. All right, so this is what we want to expand. So let's use the same formulas again, noting that since y already has an alpha squared, if we go to y squared, what is going to happen, right? I think I will stick to the other notation, so I'm going to factor out the alpha squared n squared again. I think it is going to be easier that way. So alpha squared n j plus 1/2. So I do think that it's going to be easier if I just keep it like this. All right. Okay. So now let's begin to expand this. So 1 plus alpha squared n squared 1 plus alpha squared n j plus 1/2. Close this. And I need one more parenthesis. Okay, so this to the minus 1/2. What would this be? I'm just checking if there's any way to simplify this, but I think there isn't, right? So no. Okay, what would this be? Well, this would be 1, this one, plus n times, which is minus 1/2 y, so minus 1/2 alpha squared n squared times 1 plus alpha squared n j plus 1/2. Right, and then we have to think whether we need to go further or not. Because what would it mean if we go further? That would mean that we would have this squared, right? Because we are going to y squared, which means that we'll have alpha to the 4th power multiplying everything. And well, there would be one term which would not, which would only be alpha to the 4th power. So we could include that. Is there any other alpha multiplying anywhere? I don't think there is, right? Let me double check. No, I don't think there is, because we are here. All right, so I guess we can expand. As usual, I mean, if we end up being, sorry, I'm kind of lost here. If we end up being wrong, we'll just neglect it when the time comes. So expanding to this order as well, n is minus 1/2, so we get minus 1/2 here, and then we have minus 3/2, so we have minus 1/2 times minus 3/2, and then divided by 2, so we get plus 3/8. And then we have y squared, which is alpha to the 4th power n to the 4th power 1 plus alpha squared n j plus 1/2 squared. Okay, but the thing is, when we square this, as I mentioned, there is only one term that is not going to be negligible, right? Because this will be 1 squared plus 2 times this, but alpha to the 4th, alpha squared, that's already a to the 6th, and then this squared, that's going to be a to the 8th, which is way too big. So this is in fact simply this. All right, so this is this expansion. Let's now plug it back. All right, so the expansion is this. So these two things are now equal. And let's see if there's anything we can simplify. If not, let's maybe plug it into this, because as we can see, we are actually done now, at least with all of our expansions. So the energy levels that depend on n and j are going to be mc squared times. And what do we have here? Here we have what we already found. So I think I have it in my, yeah, here it is. This, and then there is a minus 1 outside. So minus 1. And this minus 1 will cancel out this right there. And let me go to a new page where we can, simplify this quietly. Okay, so the ones, they are gone. Bye-bye. What else do we have? Then maybe let's multiply through and see what sort of magic we can work with. So let's keep the mc squared outside. And what do we have? So let's see. Here we have minus alpha squared over 2n squared. This is this first term minus alpha to the 4th power divided by 2n cubed j plus 1/2. And then we have this plus 3/8 alpha to the 4th power n to the 4th power. All right, so what can we see here? Well, we definitely can get rid of some, we can factor out alpha squared, we can factor out a negative sign, we can factor out 2n squared. We can factor out all of that. So let's begin with that and see where that leads us. So we get mc squared, and then we factor out, so a minus sign, which goes there, alpha squared, I'm sorry, there's a lot of hooping outside, 2n squared, and that leaves us, this is now simply 1, this is plus alpha squared over n j plus 1/2, and what else do we have? Then we have this, so minus 3/8 alpha squared n squared. Oh, sorry, this is minus 3/4, sorry. All right, and maybe we can factor out inside, so we can go minus mc squared alpha squared divided by 2n squared, factor 1 plus alpha squared, and what do we get here? We get 1 over n j plus 1/2 minus 3 over 4, and this is going to be n squared. And we can actually, since we already have an n here and there, we can factor out this n and this n. We can actually factor out n squared, right? N squared, but we have to compensate and multiply by n here. So we get n here, right? So alpha squared, there it is, there it is. Yeah. And finally, we can recognize that this right here is simply the energy levels of the hydrogen atom, right? So this right here is simply going to be En. So of course that En, take into consideration, this is E1 over n squared, and E1 is minus 13.6 electron volts. All right, so this is now the final form. This is what we found previously. This is the sum of the relativistic and spin orbit coupling corrections. So it was a little bit of work. We had to use the binomial theorem quite a few times, but I hope that after this you are going to be used to use it, and it won't be that much of an issue in the future. So I hope this video was helpful to you. If it was, make sure to leave a like on the video and subscribe to the channel if you haven't already. It really helps me out a lot, and it doesn't really cost you anything. So I'd really appreciate if you do that. So I'll see you in the next video. Thank you very much for watching.